When you see a problem like this, you got to remember that you have a binomial to the second power. That means you're going to write it twice and FOIL it. Okay, what I don't want you to see is just square 9x squared plus 16. I mean, that's not following order of operations, okay? So I'm going to just do the FOILing. So that gives me 9x squared. Then I do the outside is negative 12x, and then the inside is another negative 12x, and hopefully you can just do that in your head and know that that's negative 24x, and then negative 4 times negative 4 is positive 16. So that leaves me 9x squared minus 24x plus 16. Then I get to distribute that negative through. That gives me negative 3x minus 8. Don't forget to hit both of them with a negative. Now you combine like terms. I'm seeing only 1x squared, so 9x squared. Negative 24 minus 3 more is negative 27x. 16 minus 8 is positive 8. And that's how that simplifies. Okay, and you're going to find in my classroom, I think finding a percentage change is a really big deal. That's something you need to know. It's something you can't get out of high school without knowing. So what you do is, it's very easy. It's percent of change. It's like in chemistry, you're going to learn about percent of relative error. So what you do is you do the new value minus the old value divided by what it used to be, the old value times 100. I had a student once years ago that used to say this is the way to remember this, was he used to think no O. So if that helps, do it. So what I've got here is, let's see, back in May that was the old price. Today I can buy it for this price, and this is the end of June, and that is the actual price. I need to find the percent of change. How much did it change compared to what it used to be? So the 1371 is the new. It's the new. Minus the 1246, which is the old price, divided by the old price. Don't divide it by the new price. Then multiply that result by 100. So how much did it change? I found that changed $125. Dividing that by what it used to be times 100. So about a 10% change. Okay, so to clean up fractions, it's important to know how to remember these basic skills. The brackets react like that's an order of operations we do inside the parentheses. So I'm going to take 5 3/4 and add that, and that's pretty easy, just making a mixed number. And then because we're dividing these, we're going to have two mixed numbers, we're going to make this to an improper fraction. So if you remember from elementary school, we're going to rename this. The easy way is 4 times 5 plus 3, which is 23 over 4. That works because 5 is the same thing as 20 over 4, plus 3 over 4 is 20 over 4. Now I'm going to divide that by, well, let's see, 6 minus 2 1/8. Well, the way I'm going to do this, and I'll have to talk you through in my head, 6 minus 2 is 4. Then I'm going to subtract another 1/8. So isn't that 3 7/8? And if I make 3 7/8 to an improper fraction, that's going to be 24 plus 7 is 31, I believe. Now, because I'm dividing a complex fraction, I'm going to take multiply by the reciprocal of the denominator. So 23 over 4 times 8 over 31. Well, let's see. The 4 goes into the 8 twice, and I don't see any other simplification. So that's going to give me 46 if I just multiply across, right? And there's a 1 here. So 46 over 31. So now I'm going to go back up to my original equation, and what I just obtained was that cleaned up. So now I'm going to multiply that answer because I've got to follow order of operations. So 46 over 31 times 93 over 23. Now what I'm hoping you remember how to do is how to cross cancel or simplify before you multiply. I mean, the person who wants to do a lot of work is going to multiply 46 times 93, write the answer, 31 times 23, write the answer, then try to reduce that fraction. That's just too much work. So what I'm going to do is I see that 31 goes into 93 3 times. I see that 23 goes into 46 twice. And those are, of course, that's a 1 and that's a 1. So we're just going to multiply across the top. 2 times 3 is 6 over 1. And then I'm going to subtract 1 and 8/9 from that. So I can do that same kind of deal. Let's see, 6 minus 1 is 5. And then I'm going to subtract another 8/9, which leaves 1/9 left. So 4 and 1/9 is a perfectly acceptable answer. I mean, you could leave this as 37 over 9. Okay, but it's important I see your fraction work. I want you thinking. I want to see your thinking with this, not just type it into Wolfram Alpha. Okay, substitution method, something from back with in geometry. So I see I've got this bottom equation is already solved for x. So in the top equation, I'm going to replace the x with a y plus 4. Remember, what we're trying to do is find out where these two lines cross. These are two linear functions, right? So I'm going to, instead of writing x minus 2y equals 7, I'm going to write y plus 4 minus 2y equals 7. And then I'm going to combine like terms. Let's see. So y minus 2y is negative 1y plus 4 equals 7. Then I'm going to subtract 4 from both sides. So that gives me negative y equals 3, and then divide by negative 1, y is negative 3. Now we're going to go back up and find x. So this other equation is already solved for x, so let's substitute in negative 3 for y. And I'm seeing 1. So I think the answer, the point where they intersect, is 1, negative 3. But to check and make sure, I'm going to replace this answer into the top equation, which I haven't used yet. At least not since I found x or y. So I'm going to replace 1 minus 2 times negative 3. Is that equal to 7? Well, that's 1 plus 6. Yes, that's 7. So that is the solution. It's a quadratic equation. I know it's a quadratic equation because I've got an x squared term. We solve quadratic equations by setting them equal to 0. Whoops, not cubed. It's not letting me erase there. Squared, and then I'm going to bring x over, so subtract x minus 20, write it in descending order, and then Mrs. Bruckner had you use the box and diamond method. There's many other methods. I'm going to try to get you speed it up with that. I'm just going to factor this because it's pretty straightforward. X squared becomes x and x. I want the factors of negative 20 that we'll have to subtract, because right when I do the outside and the inside, they'll be opposite signs. So I'll get 1. Well, 4 times 5, 10 times 2, 20 times 1. Those are the only factors of 20. If I subtract 4 and 5, I get 1. So those are the ones I want. I'm going to have the 5 be the negative because I want to have a negative left. So negative 5, positive 4. Do a quick check. Let's see. Positive, I got x squared. That's easy. And I got negative 20. That's easy. Negative 5, positive 4 is negative 1. So we factored it correctly. So then I ask myself, remember, either one of these can be equal to 0. So when is x minus 5 equal to 0? Well, when x equals 5. When is x plus 4 equal to 0? When x equals negative 4. So those are the two solutions. And as you did some work with last year, and we'll do it again this year, these are where this parabola crosses the x-axis. Okay, this is as Mrs. Marchetti or Mr. Jopp, whoever was your 8th grade math teacher, this is just an is over up problem. It certainly can do it that way. So Greta earned 502 points, so that's her is. We don't know her points possible. We do know that it's an 89% over 100. So I can cross multiply, divide. You can also just take, if you're good with percentages, why not just divide by 0.89? Because that's doing this division first. So either way works, and you'll get the answer of whatever it is. I crunched this on my calculator. I got I got, let's see, 564.04. We'll assume that there's 564 points in this exam, on this quiz. There's a number of ways to simplify exponents. Depends on the problem what I'll do. What I'm looking at this morning is I'm going to make all these, I'm going to switch around these negative exponents first. So I'm going to write that as 2 y to the 7th, and then I'm going to bring that y to the negative 1 up on top to make it be a positive. Over, and then I'm going to bring the x cubed in the denominator, and I still get that cubed outside. I'm going to combine like terms here. So that's going to be 2 y to the 8th over x to the 3rd. Then I'm going to raise that all to the 3rd power, which means 2 to the 3rd. Remember, when you're raising powers to powers, you multiply. And there's a 1 here for the 2, right? So 2 to the 3rd, y to the 24th over, let's see, that's a 3. Yeah, so that's going to be x to the 3 times 3 is 9. We probably should write this as 8 y to the 24th over x to the 9th. We're going to spend some time working with linear equations because I want to make sure you can do them. What Mrs. Bruckner had you doing, and probably Mrs. Gardner, and Mrs. Wozni even, and Mrs. your 8th grade teacher too. I'm just going to find the slope. So 2 minus 3, remember it's change in y's over the change in x's. That's negative 1 over 9, so that's my slope. And then what Mrs. Bruckner had you do last year, and in Algebra 2, right? She just had you think about this. If you know the slope, let's just take one of these two x's and y's and find b's. Find b. I'm going to go with the 2 and the 5. Just sometimes I won't want to go with the negatives. Sometimes it's easier. So x is 5 plus b. So that's going to give me 2 equals negative 5 over 9 plus b. We could add 5/9 to both sides, which is 2 and 5/9 plus b, or equals b. Now, a lot of times we'll write, if your y-intercept is a fraction, we'll write it as an improper fraction. So I'm going to multiply 2 times 9, which is 18, plus 5, which is 23, over 9. And then to write the equation, y equals negative 1 over 9x plus 23 over 9. That's one form to write this equation. We're going to get to writing in other forms this year. Okay, simplifying rational expressions is something that takes some work. I mean, people never leave Algebra 2 with this fully mastered, so we're gonna spend some time doing it this year. Now, one way, it's a compound fraction, right? One way to do this is to flip and multiply, and since that's consistent with what we did before, I'll walk you through that. Then I'm going to show you a shortcut. I'm going to flip that, take the reciprocal of the denominator, and then that y cancels out nicely. And then what I'm seeing is this is the difference of 2 squares, so that's going to factor to, let's see, it's going to factor, red ink I want, x plus y, x minus y, and then that x minus y cancels out. So what I'm left with is, remember, these are all 1s, that's a 1 there. So that leaves me with an x plus y in the numerator and an x in the denominator. Okay, that's one way to do this problem. Okay, what can speed things along sometimes is look at the both denominators here, and I see the common factor of xy. So what I'm going to do is I'm going to multiply. I really am wondering now if this is going to be a shortcut for this problem, but I'll finish. If I started, I'll finish. So I'm going to multiply xy and xy, and what happens is say I'm multiplying the top by that, xy over 1 and xy over 1. What that'll do is that'll clean that out, and in this one it'll clean out the y's. So what I'm left with is x squared minus y squared over x times x minus y. Okay, you see that, how I got rid of that I got rid of the compound fractions this way. And then, of course, then the numerator will factor out to x plus y, x minus y, all over that x times x minus y. So that leaves me the x plus y. Same answer, couple less steps of writing. It works really slick when these are more complicated rational expressions, and you'll get that opportunity to practice those. Okay, to solve this linear equation, we're going to just get rid of the parentheses. And what we're going to remember, there's a negative 1 in front of that. So I'm going to distribute this through, this 9 through. That leaves me 18x minus 72. The 20 is not getting distributed through, but the negative 1 is. Negative 1x. Then I want to combine like terms. Before you do anything moving around any side of the equation, combine like terms. It avoids mistakes. Okay, now 72, not 76. Now what I'm going to do is I'm going to do a couple things at once, and I'll write this out for now. What I'm hoping you get to is you don't have to write this part out. I'm going to add x to both sides. You could draw a line, keep going. I'm going to add 72 to the other side. Okay, now what that does for me is that leaves me 19x equals, what is that, 87? Then I divide by 19. Divide by 19. Boy, is that, let's see. That's not a whole number, so I'm going to leave it. I'm going to leave it just like that, 87 over 19. Okay, so I hope this helps you solve this first problem set.